Welcome! In this new series of short videos, we will look at subjects of topical interest. Today we will look at how AI is defined and perceived. So what kinds of AI are there? In past videos we have looked at the three most common categories of AI. Artificial narrow intelligence, artificial general intelligence, and finally, artificial superintelligence. Before we look at these in detail, we are first going to look at intelligence in general. Like many things, intelligence can be looked at as a spectrum, with very intelligent at one end and not so intelligent at the other, and with most subjects lying somewhere in the middle of the distribution curve. But how do we measure intelligence? Measuring intelligence is a complex and many-sided task, because intelligence itself is a multi-dimensional concept. An IQ test, for example, looks at reasoning, memory, mathematical skills, and language comprehension. Today's AI systems are getting a lot better at such tasks. However, there is no single test that can measure the intelligence of a human. So likewise, if we are measuring the intelligence of an artificial system, then multiple tests must also be performed. How many times in life have you come across someone whom you previously considered to be very intelligent, doing something you regard as exceptionally stupid? Certainly with humans, a holistic approach generally gives the best interpretation of the measure of intelligence. So why should it be any different for artificial systems? So what kinds of tests could we use on an AI system? Traditional intelligence quotient (IQ) tests measure a variety of cognitive abilities including reasoning, memory, mathematical skills, and language comprehension. Emotional intelligence tests, these measure a person's ability to understand and manage their own emotions, and to navigate social complexities. Standardized tests are generally tests which are on a particular subject, and are used to group individuals into a rating system. Aptitude tests. These tests would measure the potential to succeed in a certain activity. Performance-based assessments. Tasks that require problem-solving, creativity, and practical application of knowledge, and are used to gauge ability in real-world scenarios. Behavioural assessments. Observations and evaluations of behaviour in various settings can provide insights into social intelligence, compassion, and adaptability. You could add many more tests to this list, which, while they may not apply to all humans, could very well apply to an AI. So which of these tests would the current crop of AI systems score highly at, and which would it struggle or even fail completely? The AI categories. Artificial narrow intelligence. These are limited to one task. Cars or automobiles have ANI systems. High-end search engines also fall into this category. Aircraft are flown by these systems most of the time. Facial recognition systems can find people in crowds and raise questions on the balance between privacy and public safety. Simpler systems like chess computers have been around for many years. ANI systems are already quite pervasive throughout our society. Artificial general intelligence. We are not quite there yet, although recent uses of AI chatbots have been much in the news. However, these are just ANI systems, so far. AGI refers to a type of AI that possesses the ability to understand, learn, and apply knowledge across a broad range of tasks at a level comparable to a human being. Unlike narrow AI, which is designed to perform a specific task, like playing chess or recognizing faces, AGI can generalize its learning and adapt to new, unfamiliar situations in a way that mimics human cognitive abilities. Such a system could be expected to be versatile. AGI should be able to perform any intellectual task that a human can, without being limited to a single domain or subject. Learning capability. It can learn from experience and improve over time, just like humans. Adaptability. An AGI system should be able to transfer its knowledge from one context to another, handling new and unforeseen challenges. Artificial superintelligence. These do not exist yet, and will provide significant challenges when they do. ASI refers to a hypothetical form of artificial intelligence that surpasses human intelligence in all aspects. Unlike general intelligence systems, which aim to match human cognitive abilities, ASI would exceed them, potentially achieving capabilities far beyond what humans can comprehend or achieve. Here are some of the key characteristics that might define an ASI system. Superior problem solving. An ASI system would be able to solve complex problems more efficiently and effectively than the best human minds. Advanced learning. It could learn and adapt at an accelerated pace, continuously improving its knowledge and capabilities. Creativity and innovation. ASI would likely possess unparalleled creativity, capable of generating novel ideas and innovations across various fields, by combining ideas from seemingly unrelated fields to solve complex problems. Strategic thinking. It would have advanced strategic planning abilities, capable of foreseeing and navigating complex future scenarios. As all humans lie somewhere on the spectrum of intelligence, we can probably expect AI systems to have a similar spectrum. Artificial intelligence could well be a significant future problem that we have to deal with. But what about artificial stupidity? I use an AI system to generate subtitles for these videos. However, it struggles with my Scots accent at times, and every time I mention the carriage return at the end of a line of code, the word cabbage invariably appears as cabbage. Is this stupidity on the part of the AI system, or just a lack of training data? If we look at 3 points on this spectrum, one on the left, one in the middle, and one on the extreme right. If these 3 points referred to humans, those on the lower end of the scale may not understand everything those in the middle talk about, and may understand very little about what those on the higher end of the scale talk about. Those on the higher end of the scale, being of the highest intelligence, may feel frustrated that the concepts that interest them may not be understood or be of any interest to those at the lower end. Given that it's predicted that an ASI system would be even further beyond the most intelligent human beings, would we be of any interest to them at all? Or would we be considered as mere primitives in their artificial eyes? There has been much talk about the cost of both running and training the higher-end AI systems. While there has been some movement in the cost of training such systems, for example the DeepSeek system using fewer hardware resources, this movement is likely to continue, with better utilization of hardware and software, allowing processing without spinning up an entire large language model each time it is required. However, the electricity usage in the training phase of these large language models over a period of weeks or months is considerable. The Association of Data Scientists published a paper exploring the energy consumption of large language models at different stages of application in July 2024. It was reported that in the training of GPT-3, it consumed an estimated 1,287 megawatt hours of electricity. This is about what an average American household would use over a period of 120 years. If the implementation of AI is to become pivotal within our society, these costs will need to come down. In much the same way the cost of traditional computing came down between the launch of the early mainframes, which were owned and accessed by few, to today, where everyone carries a pocket computer that is occasionally used for telephony. The other cost with AI is what it will do to our jobs market. We have seen many disruptive technologies over the years, and artificial intelligence systems, even at the general intelligence level, will probably be the biggest disruptor we have ever seen. One can only hope that it turns out to be a positive experience. On a final note, if we're going to create and train super intelligent systems, we should consider training them for both intelligence and compassion. Or with compassion, there will be at least some hope for us. Hopefully, this video will help widen the discussion about AI systems. But that's it for today. Thank you for watching.